Hey everybody, welcome back to our college algebra distance learning lessons. We are now on section 4.1, day 2, and we are still going to be focusing on exponential and logarithmic functions. And if you notice, today we're going to be really focusing on the properties of those functions. And here is our first big slide where we are going to be looking at all of these exponential function properties. In my very first column here, I am looking at the power of products property. And remember, when we're talking about a product in math, that means that we are multiplying. So look at my example down here at the bottom. I have 2 to the 4th times 2 to the 3rd. And if we notice, those bases are the same. So when we use this power of product property, our bases have to be the same. In this example, both of my bases are a 2. And so the rule for this property would be that we add the exponents. And my final answer in this example would be 2 to the power of 7. I keep that same base of 2 and I add my exponents. For my second column, I'm looking at the power of quotients. And remember, a quotient in math means that we are dividing. So look at my example here. I have division there, 2 to the power of 4 divided by 2 to the power of 3. But again, what do we notice about those bases? They are still the same. So in order to use this power of quotients, just like the power of products, your bases have to be the same or you cannot use this property. And in the power of products, we added the exponents. In the power of quotients, we are going to subtract the exponents. So if I do 4 minus 3, I end up with 2 to the power of 1 as my final answer. Notice I keep that base the same, I keep that 2, and I just subtract my exponents, 4 minus 3. Now let's look at my third column here, power of a power. So this means that we're raising one exponent to another exponent. So notice I have this 4 as my first exponent, and I have another exponent outside. So that's why it's called a power of a power. But unlike my first two examples, notice that here my base of 2 only appears once. Okay? So when my base only appears once, then we multiply the exponents. So here I would multiply 4 times 3, and my final answer would be 2 to the power of 12. Let's go to my next column, which is the power of a product. So now I have terms that are being multiplied, and I am raising them to a power, so an exponent. Notice here at the bottom, my 2 is the power for this entire product, the 3 times x. So the base still only appears once, because even though 3 is its own base and x is its own base, each of those bases are only appearing once. And what we are going to do here with the exponent is we are going to distribute it. So I'm going to take that 2, distribute it to the 3, and distribute it to the x. Please be careful because this is a common mistake. You are still distributing an exponent. So this becomes 3 squared x squared. Okay, so make sure that when you distribute that number, you still distribute it as an exponent. So my final answer then, when I simplify, 3 squared gives me 9, x squared stays x squared, and here would be my final answer, 9x squared. Let's go to my last property, which is the power of a fraction. So notice here in my example, I have a fraction, 2 over x, and then the whole entire fraction squared. Again, each base is only appearing once. So you see 2 is a base, but it only shows up once. X is a base, and it only shows up once. So what we're going to do here as well is we are going to distribute that exponent. But again, it's an exponent that we are distributing. So I take that 2 and I distribute it to the 2. I take that 2 exponent, distribute it to the x. So I end up with 2 squared over x squared. When I simplify that, 2 squared gives me 4. X squared stays x squared. So my final answer for this last example would be 4 over x squared. And so here are my 5 exponential function properties that we're going to be using throughout this lesson. And here's my first example. So from homework number 21, page 397 in the textbook, we are being asked to use the properties of exponents to simplify. Now we need to decide which property we're going to be using, but notice here that I have the same base, so that should be my first hint. And then one operation is going on between these bases. If you have two terms next to each other ever in math, then there's that invisible multiplication. So since these terms are being multiplied, I am going to add the exponents. So now what I'm going to have is 10 to the power of 3x minus 1 plus 4 minus x. So let's just go and simplify that. So I'm going to have 10 to the power. When I add my like terms, 3x minus x gives me 2x. And then when I add my negative 1 plus 4, I end up with positive 3. So there is my final answer here at the bottom. In order to use the properties of adding those exponents, I end up with 10 to the power of 2x plus 3. Here is my next example. Use the properties of exponents to simplify. So notice my bases are different. I have one base that's a 4, one base that's a 5. So I cannot use those properties of adding or subtracting. But if I have the fraction raised here to a power, I'm going to distribute that exponent. So this is what I'm going to do here. I'm going to distribute this 3z exponent. So I'm going to distribute it to the 4 to the power of x and distribute it to the 5 power of y. Okay, so this is what I should look like now. I should have 4 to the power of x raised to the 3z over 5 to the power of y also raised to the 3z. And now what do I do with these exponents? Okay, now with these exponents here, I am going to multiply. So I end up with 4 to the power of 3xz. And then the same thing's going to be true in the denominator. I multiply these exponents. I end up with 5 to the power of 3yz. Now, can I do anything else here? Can I subtract these exponents? And the answer is no. Why can I not subtract them? Because notice my bases are different. Okay? If I had the same base, then yes, I could subtract. But since I have different bases, I can't do anything else. And this right here is my final answer. 4 to the 3xz over 5 to the 3yz. Here is my next example. Use the properties of exponents to simplify. And here what we should notice is that I do in fact have the same base. So I have e, remember my letter E, standing for that special Euler value. And so since I have the same base, then what am I going to do with these exponents? I am going to subtract. So I'm going to subtract my exponents. So let's go ahead and set this up. I would have e to the power of 5x minus 2x plus 1. Notice, please be really mindful of this. Any sort of terms that are joined together by a plus or a minus, you need to have them in parentheses. Otherwise, your final answer is going to be incorrect. Because now that we've set this up, the first thing we need to do is distribute that minus sign. And so now I really have e to the power of 5x minus 2x minus 1. So when I combine my like terms, I end up with e to the power of 3x minus 1. And here is my final answer. Okay, guys? All right, let's go to our next example. Graph each function using transformations of an appropriate function of the form y equals bx. Remember, functions that are in the form y equals bx are called exponential functions because the x is there as an exponent. So this is the function that the book will tell you to graph. So make sure you enter this into y equals in your calculator. And when you enter that, this is the graph you will get, this red line. Okay? Now what you need to tell me is what the parent function should be. Now I've already graphed the parent function for you. It's here in blue. But you need to tell me what that equation would be. So what you want to do is strip away anything that is unnecessary. Look at the original function, what it should look like. Just y equals b to the x. So let's strip away this minus 1. Let's get rid of this minus 3. And my parent function would just be f of x equals 2 to the power of x. So this would be the first part of your answer. And if you put that into your calculator, again, you'll end up with this graph of this blue curve here. Now you have to tell me the transformation and what transformations took place. So let's go back to our original equation, this 2 to the power of x minus 3 minus 1. We can compare the two graphs over here to see what transformations took place, and we can also see how they relate to the equation. So notice, in my parent function's in blue. Do you see that my point is here at 0, 1? Let's find that same point in my new function, and notice that I am now at 3, 0. So what has that point done? It has gone down, and it has gone to the right. So the transformation that you would tell me is that it has gone down 1, and it has gone to the right 3. So here's the second part of your answer, and notice if we look at the equation that we were given, we can see where that comes from. This minus 1 is what controls us going down 1, and this minus 3 is what controls us going to the right. Because when you have a number with the x, it's always going to be the opposite. So since it says x minus 3, we are actually going to the right. If it said x plus 4, we would be going to the left. So here is our example of the graph and the parent function. And let's do one more of those because I know these can be a little bit tricky. So notice we're asked to graph the function and give me the parent function and the transformations. So here is the function that the book will give you that you want to graph. So notice I have graphed that for you already. So in your calculator, again, you're going to have to be doing this on your own in the homework. So make sure you actually put this equation into your calculator, because if you don't graph it yourself, it's going to be impossible for you to answer these questions. So put that equation into your calculator. You should get a curve that looks like this red curve here. And then we want to figure out what the parent function is. Remember, the parent function is in that form y equals b to the power of x. So let's get rid of all of the extra information that we don't need. So that minus 10, I don't need. That plus 5, I don't need. So my parent function would just be g to the x equals 1/3 to the power of x. And if we graphed that, then I end up with this blue curve here. Okay, this blue curve is my parent function. All right, so now let me go back in and erase a little of that, because now you need to tell me the transformation. So the parent function is always going to go through the point 0, 1. So let's look in our new function what happened to that point. So we went down, and then we also went to the left. And again, we can count it literally on the graph, but we can also look at our equation to give us some of that information. So if we have minus 10 here on the outside, that means that we went down 10. And then this plus 5, remember anything that is with the x is going to be opposite. So I went to the left 5. And if you look at my graph, that's what happened as well. I went down 10, and then I went to the left 5. So another example here, guys, of dealing with the graphs and telling me the transformations that took place. Let's go to 4-1 day 3. It's going to follow in the same vein, and today is a little two-part lesson, but we only have a few slides here with day 3. So let's look at solving exponential equations. And so when we are solving those, what you want to do is graph both equations in your calculator. Okay, so we're going to have two exponential equations and we want to graph both of those in the calculator. Then we hit second trace, and to find the solution, we want to see where both of those lines intersect. Remember, intersect just being a fancy word for cross. So if I have two lines and this is where they intersect, that would be my solution. And here is our first example, homework number 43 from page 397 in the textbook. So this is the only thing that you will be given in your textbook, okay? You need to know what to do next. So this left side of the equation, you're going to put this into y1 in your calculator. So you would put 1 minus x to the fifth. This right side of the equation, you would put that into y2 in your calculator. So you would have 2x minus 1 to the fifth. And then when you graph them, you get this graph like I have over here on the left. Remember, you have to graph this yourself in the calculator. Otherwise, you're not going to be able to answer the question. Then we go to second trace, intersect. And once we have that, we see that our two curves intersect at this point, 0.667 and 0.004. So which part of that do we care about? Do we care about the 0.667 or the 0.004? Hopefully, we know that because we're dealing with equations, notice what is my variable? My variable is x, so I care about the x part of this answer. And x is always the first part of an ordered pair. Now, 0.667 in your quiz on your test is going to show up as a fraction. So we need to know some of these common fractions at this point. That 0.667 is just the rounded version of 0.6 repeating, and 0.6 repeating is the fraction 2/3. So that would be my final answer to this equation, guys. Find all solutions to the equation. You would tell me x equals 2/3 as your answer. And let's do another example here, which I believe is our last one. Homework number 51 out of page 397. Find all solutions to the equation. Again, this equation, the entire thing, is what your book will tell you. Now, this left-hand side of the equation is what you want to put into y1. So you would put in x squared e to the power of x minus 5x e to the power of x. And then all you would put into y2 is 0. Okay? And notice, my first equation is this big curvy one. My y equals 0 is just this straight line there. Okay? Then I'm going to go to second trace. And then I'm going to go to intersect. And notice these intersect in two separate places. So I have one intersection here, another intersection here. And which part of those intersections do I care about? I always care about the x. So you're going to have two final answers. Your first answer would be x equals 0. That comes from my intersection on the left. And then my second answer would be x equals 5. And that comes here from my intersection on the right. And so that would be your two answers to this problem, x equals 0 and x equals 5. Here is your homework, guys. Homework 4.1 day 2 is numbers 22 to 38 evens. Please make sure to skip number 30. Okay, other than that, do the rest of them. For 4.1 day 3, you're going to do 40 to 52 evens. And again, make sure in Google Classroom, go to the classwork tab, go to homework, and make sure you submit these assignments under the correct assignment name. Okay, so 4.1 day 2 and 4.1 day 3, just submit a photo of your work with everything clearly labeled. So thanks guys for joining me for this lesson, and I will see you for the next one.